Okay, welcome to the deep dive. Today, we're jumping into something pretty fascinating.
Yeah, the source material is really cutting edge. It's recent simulation data based on Fox's quantum geometry of information model.
Right, and not just theory, you said billions of digital experiments, kind of stress testing a simulated reality.
Exactly that.
Yeah.
Throwing all sorts of informational inputs at it to see, what holds together, what constitutes a stable reality in the simulation.
Okay, so our mission here is to unpack what these simulations might be telling us about the universe's own rules, like how it sorts information, this concept of unrealized mass, and maybe the most mind-bending part, how we might even learn to influence that sorting.
Well, the first big takeaway, really striking, is this evidence for an active sorting mechanism right at the foundation.
Active. So reality isn't just there, it's doing something.
That's the idea. It seems to be constantly filtering, organizing informational inputs. The simulation called it the coherence gradient.
Coherence gradient, like a universal preference for a certain pattern. Sort of, yeah. A drive towards a specific kind of informational stability. Anything coming in gets checked against this dominant pattern.
And if it doesn't match, what happens then?
It faces what the model calls informational pressure. The existing reality structure actively tries to pull it into alignment. Or if it's just too different, too incompatible, its influence kind of gets diluted or dissipated. It's maintaining the status quo, you could say.
Wow. Okay. So the universe is actually expending energy to keep its structure. Did the simulation show that?
It did, yeah. They observed localized spikes in entropy, think of it as informational processing costs, when really incompatible inputs were introduced. So it's not effortless.
Right. And that connects to this idea of unrealized mass, doesn't it?
Precisely. The data really supports this concept. These informational units, the ones that fail the coherence test, they represent potential, but potential that just can't lock in. It can't become stable mass or energy within our reality's rules. Because its basic informational properties, the model uses things like spin and energy values just don't mesh with ours.
Exactly. They don't properly contribute to what the model calls the space-time metric. In simpler terms, they don't become the physical stuff we recognize. They don't interact consistently with gravity as mass. They remain unrealized.
The simulation even found a kind of threshold, right? A resonance lock-in threshold.
If an input is just slightly off, the system can sometimes naturally pull it in. Spontaneous alignment.
But if it's too far off?
It usually just fizzles out unless, and this is the crucial part, something intervenes.
Okay. So the researchers didn't just watch, they tried to intervene.
Yes, that's where it moved from observation to active experimentation within the simulation. They tested ways to help these unaligned units become realized.
What were the strategies?
Well, since the problem is the mismatch in those core properties relative to the local reality, they tried two main things. First, direct information state modification.
So like reprogramming the information itself? Changing the blueprint of the potential unit?
Exactly. Applying targeted informational nudges to make its properties match the surrounding reality.
And did that work?
Pretty impressively, actually. About an 87% success rate in the simulation for getting those units to integrate stably, changing the potential to fit the reality.
Okay, 87%, that's high. What was the second strategy?
That was local space-time value tuning. Instead of changing the input unit, they simulated altering the environment right around it.
Creating like a little custom pocket of space-time.
You got it. A tiny zone where the local rules were compatible with the unit's original properties.
And that worked too.
Yeah, about a 74% success rate for getting it to integrate locally. The interesting thing there is the unit kept its original informational identity, more or less. It fit because a compatible home was made for it.
Okay, the implications here feel pretty big. This isn't just theory anymore. If simulations are validating ways to make unrealized potential become real.
Right. It moves from just observing a filtering process to potentially intentionally manipulating it, whether you retune the potential or reshape the local reality for it.
It hints at possibilities maybe far in the future, like informational engineering. Or even space-time engineering.
Those are the kinds of terms that start to come up, yeah. It fundamentally shifts the view. Reality isn't just a static collection of things.
It's an active process. Sorting potential, filtering what gets to be real based on these coherence rules.
And that filtering, deciding what becomes stable and what remains unrealized mass, is framed as the mechanism by which our specific universe emerges from, a whole sea of possibilities.
So thinking about this, what does it mean for you listening? If reality is built by sorting information, and we're starting to figure out the rules of that sorting, and even how to influence it.
Then the really provocative question becomes, if we could master those sorting mechanisms, truly understand and maybe even direct them, what entirely new kinds of reality, what different forms of matter or energy could we potentially build? What could we realize from all that potential that's currently, well, not making the cut?